this video, we continue with conic sections, but this time with hyperbolas and parabolas. Let's start with hyperbolas. Given two focus points, f1 and f2, a hyperbola will be formed by all the points, like this one, for which we have a pink distance to f1 and a green distance to f2. And what happens for every point in the hyperbola is that green minus pink is equal to a constant, and it's 2 times a. And this happens for every point in the hyperbola. So, for example, if now I take a point here, then this point will be a red distance from f2 and blue distance from f1. And what happens here is that blue minus red is equal to 2a. This is very similar to the ellipse, only there's a minus sign instead of a plus sign. And in general, hyperbolas look like this. So, if we draw the axis, we can mark this point, and we're gonna call it vertex 2, and this one vertex 1. So if we look at the vertices, then v1 is pink distance from f1 and green distance to f2, and we know that the difference between green and pink is 2a. So what that's telling us is that the vertex 1 is at the coordinate minus a, 0, and in vertex 2 it's at a, 0. And we're gonna call a constant c for the coordinates of the focus points. f1 is at minus c, 0, and f2 is at c, 0. Notice that this hyperbola has its center in the origin. Working with these differences, as we did with the ellipse, we can get to the equation of a hyperbola, which is x squared over a squared minus y squared over v squared equal to 1. So this is the equation of a hyperbola with center in 0, 0. Where p is a constant that satisfies that p squared is equal to c squared minus a squared. Let's work a bit on this equation. And let's try now and isolate y. So we get that y squared over v squared equals to x squared over a squared minus 1. So then y squared equals b squared over a squared times x squared minus a. And then y equals plus or minus b over a times the square root of x squared minus a squared. And what this is telling us is that if we have the axis, we can form a rectangle of sides 2a and 2b, so we're gonna have this rectangle, and now we can mark the linear functions. And the hyperbola will look like this. So these two lines, the y equals minus b over a x and y equals b over a x, are two oblique asymptotes for the hyperbola. And here we can also see that the vertex is in a0 and in minus a0. Let's try now and do an example. We are given this equation. We know the equation for a hyperbola looks like this. So now we can deduce that 9 will be a squared and 4 will be b squared. Then a equals 3 and b equals 2. And now we can use these two numbers using that b squared equals c squared minus a squared and calculate c, because c squared is going to be b squared plus a squared, and that is 4 plus 9, which equals to 13. So then c equals the square root of 13. And what this is giving us is the two focus points. One will be in minus the square root of 13, 0, and the other one in the square root of 13, 0. Also from A, we can say that the two vertex points will be minus 3, 0 and 3, 0. Now let's calculate the two oblique asymptotes. They were y equals plus or minus b over a x. b over a equals plus or minus 2 over 3x. So with all this information, we can now plot our hyperbola. The two vertex points are at minus 3, 0 and 3, 0. That is, one is here and the other one here. The two focus points are in plus and minus square root of 13, 0. That is something around here and here. And now we have to plot the oblique asymptotes. So starting from the origin, we move 3 units in the x-axis and 2 in the y-axis. The same in the negative side because it's plus or minus. And like this, we got this rectangle of sides 2a and 2b. And with this we can plot the asymptotes. And now we can plot the hyperbola. These type of hyperbolas are called horizontal because they look towards the left and towards the right. If a hyperbola looks like this, with the focus points here, the two vertices, and the oblique asymptotes, that is when the hyperbola is looking upwards and downwards, then it's called a vertical hyperbola. The asymptotes are y equals a over vx and y equals minus a over vx. The focus points are on 0, c and 0, minus c. The vertices are on 0, minus a and in 0, a. And the equation for this type of hyperbolas is y squared over a squared minus x squared over v squared. Notice that now the variable that has the minus sign is the x. Another thing that can happen is, given the axis, that we can have a hyperbola like this one. This hyperbola is not centered in the 0, 0, but it is in h, k. We know the form of this hyperbola, and we know that we have to move this hyperbola upwards, k units, and towards the right, h units. And we've seen this in previous videos when we worked with functions. So we have the formula for the y-hyperbola. Now to shift towards the right, what we have to do is subtract h to x. And to move it towards the left, we have to subtract k from y. So now this is the equation for a hyperbola with center in hk. Now let's look at the vertices. So we had this one in minus a, 0, and this other one in a, 0. But we had to move each of these vertices h units to the right, making the x coordinate a plus h and minus a plus h. And the y coordinate was moved upwards k units, so the y coordinate will be 0 plus k. And so the new coordinates for the vertices are a plus h k and minus a plus h k. The same thing will happen to the vertices. Here we had one at minus c, 0, and this one at c, 0. But now this vertex, the x coordinate was moved h units, so it would be c plus h and k units upwards. And the other one will be the same, minus c plus h, k. And the same will happen to the oblique asymptotes. The oblique asymptotes were y equal to plus or minus v over a x. But now these oblique asymptotes will be the same as these ones, only shifted. So instead of y, we had to, like we did here, subtract k, and this will be equal to plus or minus v over a, and here instead of x, we'll use x minus h. So working a bit on this, we get that y equals plus or minus v over a x minus h plus k. And this will be, with the plus and the minus, we have two functions, two linear functions that will define the oblique asymptotes for this new hyperbola. Let's now do an example of a horizontal and vertical shift. We are given this expression. What we're gonna do is, on these two terms, take common factor 4. So this gives us 4 times x squared plus 4x. And on this second term, we'll take common factor 9. And so we get y squared minus 2y. And this all equals to 29. We will add up a number here plus 4. And so that the equality holds, we'll also have to add 4 here. Only here we had 4 times 4, it's 16 we've added. And on this term, we're gonna add plus 1. But we're actually adding 9 times 1. With a minus sign, it's minus 9. So, now working with this, we have 4 times x plus 2 squared minus 9 times, and again we now work on this term, and we get y minus 1 squared. And this all equals to 29 plus 16 minus 9, which is 36. Now what we're gonna do is divide by 9 times 4. And so we get x plus 2 squared divided by 9 minus y minus 1 squared divided by 4 equals to 36 over 4 times 9, which equals to 1. First, here we have to pay attention that the term that has the negative sign is the one that depends on the variable y. So this tells us that it's a horizontal asymptote, the one we're trying to plot. Next, remember here we have a squared, and here we have b squared. So this tells us that a equals 3 and b equals 4. Another thing to notice is these two terms here. Remember this was minus h, so h equals to minus 2, and this one was minus k, so then k equals to 1. Then the center is on minus 2, 1. Now, using that a equals 3 and b equals 4, we can calculate c, because c squared equals b squared plus a squared. That is 4 plus 9, which equals 13. And this tells us that c equals the square root of 13. And now we can use this information to get the focus points. The first focus point will be in minus square root of 13, but shifted h units, so it would be minus square root of 13 minus 2. And then it shifted k units upwards or downwards, so that is 1. And the same with the second one, square root of 13 minus the h, 1. And now we can get the vertex points. The first one will be in minus a plus h, so that is minus 3 minus 2. And then the k coordinate, 1. And the second one will be in a plus h, k. So now we can draw the hyperbola. Let's start by marking the vertices. The first one is minus 5, 1, and the second one is in 1, 1. Now the focus points are minus square root of 13 minus 2, that is about here, and the other one about there. The center is in minus 2, 1. Now the only thing left to plot are the oblique asymptotes. And to do so, what we're going to do is use the common values of a and b. But instead of starting from the origin, we're going to start from our center point, because that way we are subtracting k to y and subtracting h to x. So starting from the new origin, the new center, we're going to have to move 3 units in the direction of x and 2 units in the direction of y, because remember that p was equal to 2. The same in the negative part, that is 2 units downwards and 3 units towards the left, 2 units upwards and 3 towards the left, 2 units downwards and 3 towards the right. So we have the rectangle of sides 2a and 2b, and with this we can plot our asymptotes. They're gonna be something like this. This is a sketch, so it's all very approximate. And now with all these drawings done, we can plot the hyperbola. Let's now continue with a parabola. Given a focus point and a directrix, a parabola is formed by all the points that are equidistant to the focus point and to the directrix. So, if I take a point here, for example, this point is at pink distance from the focus, but it also has to be pink distance from the directrix. When we plot all these points, we get something like this. Let's think for a moment about this point, the vertex. This point has this blue distance from the focus point, we're gonna call P, and also blue distance for the directrix, which is also P. If we center this vertex in the 0, then we get that the directrix is at y equals minus p, and that the focus point will have coordinates 0, p. And now with this information, we can get the formula for the parabola. So to do this, we're going to take a point with coordinates x, y. Let's call this point Q. Q has pink distance to the directrix and intersects the directrix in a point we're going to call A. It is also at green distance from the focus point, and these two distances are the same. Let's first write the green one. So QF, the distance is the square root of x minus 0 squared plus y minus b squared. If you don't know the formula I'm using, I recommend you go watch the first video about conic sections, where we work out the definition of distance. And now the distance from Q to the point A will be the square root of, well, let's first think about the point A. It has the same x coordinate as Q, which is x, and its y coordinate, as it's over the directrix, is going to be minus b. So then the distance will be x minus x squared plus y minus b squared. Now these two distances are the same. So we have the square root of x minus 0 squared plus y minus b squared, and this has to be equal to the square root of x minus x is 0 and then y plus b squared. We can cancel out the square root with the power 2 and then square both terms in the equality. So what we get is that this square root will cancel out with these two, leaving us with x squared plus y minus b squared, and this will equal to y plus b squared. Now let's work on this expression. We have x squared plus y squared minus 2yp plus p squared, and this all equals to, working on this expression gives us y squared plus 2yp plus p squared. We can cancel out some of these terms, y squared and y squared, p squared and p squared, and we're left with 2yp on both sides that will add up to 4yp. And so like this, we got the equation of a parabola with focus in 0p and directrix in y equal minus p. Something important to notice is that this parabola is facing upwards, and so it is a vertical parabola. What can also happen is for the parabola to be horizontal. In this case, we would have the directrix here and the focus somewhere around that point. Let's plot the axis. And now it's easy for us to notice that the focus point will have coordinates p0 because now it's over the x-axis, and the directrix will be of the form x equals minus p. Now, working as before with grabbing a point P and working out the distance pink equal to the distance green, we get to the formula y squared equals 4px, and this is the equation of a parabola with focus in p0 and directrix in x equals minus p. Notice that when the parabola is horizontal, the square term is y, and when it is vertical, the square term is x, and these types of parabola, the vertical ones, are the ones we're most familiar with as quadratic functions. So let's continue with an example. Let's say that we know that the focus of a parabola is on the point 2, 0, and the directrix is the line x equals to minus 2. So one fast thing to know is, given the directrix, we know that p equals 2. the directrix is a vertical line, and that tells us that the parabola will be horizontal. So let's draw the axis. And then the parabola will look like this. And the equation, first notice it is horizontal, so it will be y squared equals 4px. And we said that p was equal to 2, so y squared equals 4 times 2 is 8x. Now, as we did with the hyperbola, it can also happen that given the axis, we can encounter a parabola here. This parabola has its focus here and its directrix there. But we know this parabola is a shift from this one. And this other parabola has here the focus point and the directrix. This parabola has its center in 0, 0, and this one in hk. So what happened is we moved the white parabola h units to the right and k units upwards. So now we knew the directrix from the white one was in y equals minus p, but then the horizontal shift will not affect y equals minus p, but the vertical shift will. It will move it k units vertically, making the new directrix y equals minus p plus k. And now the focus point, well, it was in 0p, and we moved it to the right h unit, so the new one will be in h, and instead of p, it will be p plus k. And as we did before, the white parabola had formula x squared equals 4py. But for the new one, we had to remove h units from x and remove k units from y. And like this, we get the equation of a parabola with vertex in hk. Let's do an example. We are given that the vertex of a parabola is on minus 2, 4, and the focus point is on minus 2, 7 over 2. And the first thing to notice is that the x coordinates for these 2 points are the same. So what this is telling us is that if one point is here, and this is the x-axis, the other one will be here or here. So if one is the vertex and the other one is the focus, then the parabola will be vertical. Now, as the parabola is vertical and it's not centered in 0, 0, because none of these components are 0, then we know, because these two elements are the same, that this is h. And then the vertex, as it moved from 0, 0 to hk, this is k. And then this number, the focus, will be p plus k. So we know that p plus k equals to 7 over 2, and k equals 4, so p plus 4 is 7 over 2. p is 7 over 2 minus 4, and this gives us that p is minus 1/2. Once we know h and k, we can write the formula for our parabola. It will be x minus h squared equal to 4p times y minus k. And k is 4. Now, using that p is minus 1/2, we get x plus 2 squared equals to 4 times minus 1/2 y minus 4. So x plus 2 squared equals minus 2 y minus 4. And this is the equation for this parabola. Now let's think about the directrix. So we have a vertical parabola with a focus here, the vertex, and here the directrix. And the axis is somewhere over here. So the directrix moved from here, from minus p, to minus p plus k. So the directrix is y equals minus p plus k. Minus p is minus 1/2 plus k, which equals to 4. So the directrix will be in y equals 4.5. Now we can use all this information to plot the parabola. The vertex is on minus 2, 4. So it is here. The focus point is on minus 2, 7 over 2. So there is around here. And the directrix is on y equals 4.5. So it's something like this. And now the parabola will be like this. For a more accurate plot, you can try and calculate the roots and the y-intercept using this formula and your knowledge of quadratic functions.